So as earlier suggested by a number of you, you suggested that we do fluid flow and magnetic effect of an electric current. So we'll begin with fluid flow as we proceed. But before we start, Albert can take us to the opening prayer.
Let's believe and pray. Dear Heavenly Father, I come for this special morning, thanking you for the gift of life. As I'm going to begin this session, may us guide us, protect us. In Jesus' name, we pray, just now believe. Amen.
Amen. Thank you very much. So we begin from fluid flow. We'll do quite a number of concepts from fluid flow. So in fluid flow, it is the last topic of Form 2. That is chapter 10. And in every topic, we have a specific objective that the learner must be able to know before the end of the topic. And for this fluid flow, by the end of this lesson today, we can finish the topic today. We are able to finish the topic today because it is we are just reminding ourselves what we did earlier. So by the end of today's lesson, you should be in a position to describe or differentiate streamline flow and turbulent flow. By the end of this lesson, again, you must be in a position to derive the equation of continuity. By the end of this topic, you should be able to explain the Bernoulli's effect or state Bernoulli's effect and the Bernoulli's principle. By the end of this topic, or by the end of this lesson today, we should be able to solve some numerical problems. We should be able to solve some numerical problems involving equations of continuity. So we'll begin from the first part. And the first part of this topic is more of theoretical, more of definition and knowing some terms. Earlier, I used to think that a fluid is only a liquid, but after some time, or after reading, I noticed that a fluid is not a liquid only. So we begin by knowing, in this topic, fluid flow, we start by knowing what a fluid is. So a fluid refers to any substance that is capable of flowing due to pressure difference. And it includes both liquids and gases. So in this topic, we'll be dealing with both liquids and gases. And we have examples of fluid flow. We have some examples of fluid flow in our real life situation. One of them, a good example, even from your homes, is the perfume spray from a perfume bottle. I'm sure a good number of you normally uses this, and that one will also be handled in fluid flow. We have the flow of water along a river bed, and even the smoke from chimney. I will share the notes as we continue, and questions as we continue. So, those are some basics you must know. We have types of fluid flow. We have two types of fluid flow. One of them is streamline or steady flow. The other one is turbulent flow. As we said earlier, we must begin by knowing the difference or by describing the two of them. We must begin by describing the two of them. So in steady flow or streamline flow, I want someone to, because this revision, we have a YB. Can you tell us what, can you describe streamline or steady flow?
In streamline or steady flow, the particles flow in the same direction and velocity as the liquid, as the fluid.
Yes, thank you very much. It is a flow in which at any given point, each and every particle of the fluid travels in the same direction, as you have said, and with the same velocity. Before we continue, we must also know the meaning of streamline. What is a streamline? We have been using streamline at the car is streamlined, the plane is streamlined, the bird is streamlined, and so on. What is the meaning of this streamline? Denzel? Denzel?
The meaning of that streamline is path followed by a fluid path.
Yes, it is a path followed by a particle in a streamlined flow. It is a path, meaning any path has some direction. Kuna mahali inaelekea. It is the path followed by a particle in a streamlined flow. I have already shared some notes here, the notes on the screen. I've already shared the notes on the screen. So that is those are the basics. We also have some characteristics of streamline flow. We have some characteristics of streamline flow. From this diagram, you have already seen the how streamline flow is in the tube. This is a fluid. In a fluid. And it is important to note that streamlines do not cross each other, but are closer where the fluid is moving faster. They don't cross each other, meaning each streamline equals straight. We'll get the characteristics of streamline here. So one, the streamlines are in parallel to each other, meaning they don't cross each other. Number two, they should also they should be steady or they are smooth. This will be different from turbulent flow. This will be different from turbulent flow. We have already mentioned some bodies which are examples of streamlined bodies. You can see the examples of streamlined bodies on the diagram. We have the fish. You can also see the car. And in every body, in every streamlined body, you can see the path followed by that particle. The Tulisema fluid is both, they are both liquids and gases. So in a tube itakuwa fluid. In a scenario like this one of streamlined bodies, e.g. the car, the jumbo jets, and so on, we'll consider gases here. And this introductory part is very important for when we'll be explaining the applications of Bernoulli's effect. Very important. We have number 2. We already know the streamlined flow and the characteristics of streamlined flow. We have another type of fluid flow, turbulent flow. This one is a flow in which the speed and direction of the particles passing at any point vary with the time. They normally form eddies, as you can see here. So it is a flow in which the speed and direction, unlike the first one, it is a flow in which the speed and direction of fluid particles passing at any point vary with the time. We have instances of occurrence of turbulent flow. We have some examples here. When abrupt change of cross-sectional area of the tube flow from a smaller cross-sectional area to a larger cross-sectional area. That is one example. Another one is an obstacle is placed on the path of streamlines and blocks or breaks the streamline. You can see they are forming eddies. And the direction of motion of a body is different from the direction of the streamlines, of the direction of the eddies. So meaning the flow is interfered and the time is not constant. We have a varying time because of different cross-sectional areas. We have characteristics of turbulent flow. You can see the streamlines are not continuous as compared to steady flow. The streamlines are not continuous. Kuna mahali inaisha na ina form eddies. The streamlines are not continuous. Also, in turbulent flow, the particles do not travel in the same direction and have different velocities. They have different velocities because of different cross-sectional areas. So it is also important to note that we have that critical velocity, the speed of flow, the speed of fluid flow, beyond which the fluid exhibits turbulent flow. And we have been told that it is sometimes abrupt. In some scenarios, it is abrupt from one from a smaller or from a larger. It can either be from the larger cross-section to a smaller cross-section or from a smaller cross-section to a larger cross-section area. When bodies which are not streamlined or non-streamlined move in fluids, they cause eddies. Now, the term eddies come from turbulence in the fluid. So the eddies are the ones we in the diagram above. So they form eddies behind it. That is the difference now between the streamline and turbulent. This other part of volume flux is leading us to the numerical problems we were talking about, because we will get some formulas here. And this is the most commonly tested part, including, I don't remember very well, but I believe it was also tested in the end of term exam. A calculation from this part, calculation question. It can either be theoretical question whereby you are required to differentiate or to describe. You can also be asked to state the Bernoulli's effect or the Bernoulli's principle. That is somehow theoretical. You can also be asked to solve some numerical problems here, and it can take the more than 8 marks in section 2, because we'll ask the volume flux, the mass flux, and including some applications there. So be very keen to this part. We'll begin by knowing how we get this formula of volume flux. And the volume flux is also known as the flow rate. Wakati mwingine inaweza ulizwa kama ni calculate the flow rate. So kama ujui flow rate pia ni volume flux, you can easily leave a blank space. So it is important to note that the volume flux is also the flow rate. And this volume flux is the volume of a fluid passing through a given section of a tube. Can you underline that volume? This is the volume of a fluid passing through a given section of a tube of flow per unit time. So from the formula of volume, kabla tujaongeza flux, tukisema tu volume, you know the formula of volume can be gotten by volume is the same as cross-sectional area multiplied by, kama imelala chini kama pipe, tutasema multiply by length. If we are considering a body in a vertical position, it will be the height. So the volume can either be the cross-sectional area multiplied by the length, if it is horizontal, or volume is also cross-sectional area multiplied by height, if it is vertical. So for this case, we are considering a tube, meaning from the diagram we can see a tube with uniform streamlines. So for this case, volume, as we consider this, volume will be the same as the cross-sectional area multiplied by the length. So can you write somewhere volume is equals to, the volume is equal to cross-sectional area multiplied by length. In mathematics, it can also be the base area multiplied by the length, base area multiplied by the length. Then you represent the cross-sectional area with A and the length with D. Let the length be D, meaning V now will be A multiplied by D. Hiyo ni kama wakati hatujaongeza flux. Na tukiongeza sasa volume flux, this is where per unit time inatokea sasa. This is where per unit time inatokea. So we already have the volume to be cross-section area A multiplied by the length, which is D. And when we say the volume flux, it will now be the volume over time. Volume flux is volume over time. But we have the velocity. We know velocity. Velocity is equals to displacement over time, where displacement tumejifunza displacement kwa, there is a point where we said, as we were doing linear motion, there is somewhere we said there was a formula of velocity in fluid flow. This is where we are referring to. Velocity can be d over t, but in linear motion tulikuwa tuna represent displacement kwenye s. Therefore, the volume flux can be, we replace d over t with velocity, so it will be the velocity multiplied by area. So the formula for volume flux is velocity multiplied by A. Volume flux is V multiplied by A. So when writing the formula of volume flux, don't make short forms. You write in full. Volume flux is equivalent to V multiplied by A. That is the first case. We'll do some some questions after this. So can you now note the formula, the first formula from definition, that volume flux is equals to V over T, and also note the formula after deriving that volume flux is V multiplied by A. Volume flux is velocity multiplied by cross-sectional area A. In some questions, you will need the two. In some questions, you will need the two to get the answer. You will need the formula volume flux equals to volume over time, and you may also need volume flux is equals to velocity multiplied by the cross-sectional area A. Mass flux tutafanya tu venye tulikuwa tumesema ile. In fact, from the definition of mass flux, we can get a formula. Mass flux is the mass of a fluid that flows through a given section of a tube of flow. Tukiongeza sasa per unit time inakuwa mass flux. So when we factor in time, ndio tunaongeza flux. So can we just write the can we first write the formula of a mass from the knowledge you got in Form 1? We know that density is equals to mass over volume. Mass is equals to density multiplied by volume. You know, wakati ujiongeza flux, the moment unaongeza 2 per unit time, inakuwa ni mass flux. So the formula for mass flux will now be density multiplied by V volume over time. Density multiplied by volume over time. But kuna mahali tulisema in volume flux that V volume flux is equals to volume over time. Kuna mahali tulisema kwa volume flux wakati tulikuwa tunaanza tukasema volume flux is equals to V over T. Na after derivation pia bado tunaweza pata volume flux is equals to velocity multiplied by the cross-sectional area of the fluid, of the tube. Now, so mass flux, if we replace volume flux with if we replace V over T with volume flux, mass flux will therefore be the density rho multiplied by the volume flux. But we already know that the volume flux is V velocity times area. That is how we get the mass flux to be density rho multiplied by V multiplied by A. Let us do some calculation questions so that it makes some more sense, so that the formulas make some more sense here. Question number 1. Question number 1. Water flows through a horizontal pipe. Can you follow this now? Water flows through a horizontal pipe at a rate of 1 meter cube per minute. Determine the velocity of the water at the point where the diameter of the pipe is 1 centimeter. From the question, the question has mixed different units here. The first part of it, the rate is 1 cubic meter per minute. Na tunajua the SI unit for time is seconds. So we will need to change, or we'll need to convert the minute into seconds. We'll need to convert the minute into seconds. So we can, like we did in linear motion, we can first make some brief notes from the question also in this one. We have been given the rate, meaning that is the flow rate. We have been given the flow rate to be 1 meter cube per minute. That is the flow rate before converting anything. We don't know the velocity of water. We don't know the velocity of water. So we can indicate V is equals to a question mark. We don't know the velocity of water at that point. But we have the diameter of the pipe. Diameter is not the length. We have the diameter of the pipe, and the diameter is not the length. So we'll use the formula of volume. How can we find the volume of a cylindrical? What is the formula to find the volume of a cylindrical instrument? We'll need to use, when we write the formula V, for instance, the formula of finding the volume of a cylinder, Enos?
Pi r squared h. Pi r squared h.
Pi
R
pi
squared.
r squared h. Lakini sasa tuta replace h na, we'll replace h with the length because it is a pipe and it is horizontal. So which part of that formula is the cross-sectional area? Which part of this formula is the cross-sectional area? Enos?
Pi r squared.
Pi r squared.
Yes.
So thank you very much. Meaning the part of pi r squared, we already have Elvis, you want to say something? Now that we have the diameter, that diameter can give us the cross-section area. Can give us the cross-section area, pi r squared. We can use pi. We have not been given a specific. We can use pi to be 22/7 or 3.142. We are not limited. So let us begin from finding the cross-section area of this pipe. We have been told that the pipe has a diameter of 1.00 centimeters, which is also the same as 1. Now, can we get A, which is the cross-sectional area, by using pi r squared? Can use 22/7 multiplied by what will be our r? We'll need to change, since the flow rate is in cubic meters, we already have the flow rate, which is one cubic meter per minute. And now, since the flow rate is in meter cube, we also need to change this centimeter to meter. But this is the diameter. Lazima tuweke over 2 mahali fulani kwa sababu that is the diameter. And we should also square this radius. So can you give me the cross-section area of this pipe, which has a diameter of 1 centimeter? Can you give me the value? It will be the same as 22/7 multiplied by, we can even write 1/100/2. Tunasema 1/100 ndio change into meters, then divided by 2 ndio equal radius. Then we square everything here. We get some value. What is the value of the cross-section area? What is the value of the cross-section area? (22/7). You here, lazima sasa ukuwe na calculator yako hapo. Lazima ukuwe na calculator hapo. No, apart from menos. Apart from menos. Apart from menos. (26,377). 26,377. 26,377.
7.8571 times 10 to the power of -5.
7.8571
times 10 to the power of -5.
That is the cross-sectional area.
Yes.
Yes, that is the cross-sectional area. But we now we write the formula. Write the formula now. We have in the formula, we have the flow rates. The flow rates, to share flow rates is equals to 1 cubic meter per minute. Hatujui V. V for this case is the velocity. V in equation mark. We don't know V. Tuko na diameter, which can also give us the radius. And this diameter can also give us the cross-sectional area, since it is the diameter of the pipe. And we already have found the cross-sectional area to be 7.851 multiplied by 10 raised to the -5, multiplied by V, which we don't know, is equals to the flow rate. But we know the flow rate. Now, while we were defining the flow rate, we say that the flow rate or the volume flux is the volume of a liquid passing a given section, meaning hapo juu, the numerator will have the volume, and the unit of volume is cubic meters, and the time, the SI unit for time is in seconds. So we'll not use the flow rate to be 1 cubic meter per minute. Instead of minute, we change the minute into seconds. So the flow rate, our flow rate for this case will be 1 cubic meter over 60 seconds, so that we deal with the values in its SI unit. We have already changed the diameter to be in meters, meaning the answer we get for velocity will be in SI unit. Now, give me the answer. And make sure you make sure you write the formula. Make sure you write the formula. Give me the answer in 6 significant figures so that I know that you are not copying. Give me the answer in 6 significant figures. The answer on the screen is in how many significant figures? The answer on the screen is in 5 significant figures. Can you give me the answer in 6 significant figures? And when you are giving the answer in, for example, 6 significant figures, you consider the 7th value, then you round off if necessary. Round off before giving me the answer. In 6 significant figures. The formula is very easy. Flow rate is equals to cross-sectional area times velocity. But the answer you get depends on how you organize your work. The formula is short, but the working needs some validation. The answer is in 6 significant figures. The answer in 6 significant figures. This one is Enos. Enos?
Teacher, can you kindly repeat the question? It's not very clear.
I say give me the question is on the screen, but I need the
Yes, it's
answer
not
in.
clear.
It is not clear.
Yes. Yes, it's better.
I need the answer in 6 significant figures. So, Raphael? 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 Raphael has disappeared. Emmanuel?
If I use the pi as 3.142, I get the answers 212.222.
212.222, which
Yes.
is also correct. What is the unit? What is the unit?
Meters per second.
Yes. I think we can proceed to the next question now. Question number 2. This is question number 2 here. In the figure below, the tube ABC is filled. This is now comprehensive question. These are comprehensive question. It can take up to more than 6 marks. More than 6 marks, because it has part 1A, part A, B, and C. meaning we should be more keen here, so that because the part A we'll use part A in part B, and we can also use part B in part C. In the figure below, the tube ABC is filled with a liquid. The piston moves from A to B in 1 second. What is the volume of the liquid in point AB? What is the volume of the liquid in point AB? So from the diagram, we have a tube of different cross-sectional areas. We have part AB, we have part BC, and we also have part CD. But question A is asking for the volume of the liquid in part AB. So we consider part AB for the first question. We have been given the length to be 8 centimeters. We have been given the cross-sectional area to be 1 centimeter square. Calculate the volume. As earlier stated in the when we were deriving the formula, we know that volume is the base area or the cross-sectional area multiplied by the length if it is horizontal. We have the cross-sectional area, which is 1 centimeter squared. We change this 1 centimeter squared. If you want to get the unit in meter squared, if you want to get the volume, we have been asked the volume, but the question is not limiting us to give the answer in SI unit, but it is good to leave the answer in SI unit. So we change this cross-sectional area, which is 1 centimeter squared, to meter squared. And you know the relationship between meter squared and centimeter squared is 10,000. That is why we are multiplying 1 multiplied by 10 raised to power negative 4. Hiyo ni kama 1 over 10,000. We can also use 1 over 10,000 direct multiplied by the length. We have the length to be 8 centimeters. 8 centimeters tunaweza weka multiplied by 8 over 100 or times 10 raised to power negative 2. We get the first answer, the volume of liquid in AB. Question B, what is the velocity of the liquid between AB? What is the velocity of the liquid between AB? Can we now calculate the velocity of the liquid between AB? Velocity of the liquid between AB. Someone to guide us through the steps. Someone? How will we get the velocity of the liquid between AB? We have already found the volume. Tuko na volume already hapa. This is a point where nilisema wakati tulikuwa tuna derive the flow rate, we have 2 important formulas in that derivation there. Someone. 261111. What is your name?
My name is Mohammed, sir.
Yes, can you take us through how we'll get what is the velocity of the liquid between A, B. We already have the volume between A, B.
Since we were told that the velocity, since we finally got the volume is 8 times 10 power negative 6 cubic meters.
Yes.
Then, since sorry, my internet is bad. Since we've gotten that the volume is 8 times 10 power negative 6 cubic meters,
Mm-hmm.
then volume over time is flow rate. So,
yes, volume over time is flow rate.
So you take 8 times 10 power negative 6.
Yes.
Sorry, sir. I think there's a problem with your pad.
Okay, you need some time. Someone to proceed. Albert. Albert. Four 13.
Yes, so when the part was said to be
What is your name? What is your name?
Tobias.
Tobias.
Yes.
Continue.
So the formula, we use the formulas of getting the volume flasks. So the first one would have been the cross-sectional area times the distance over time, which
Yes.
will be the volume flux of that region AB will be 8 times 10 power negative 6.
Yes.
So we use that volume flux for another equation, which is velocity times cross-section area. So it will be the volume flux 8 times 10 power negative 6 is equals to velocity times the cross-sectional area is 1 centimeter squared, so convert it to meters squared by dividing it by 10,000. So I found that the velocity is 0.08 meters per second.
Yes, 0.08 meters per second. You got the answer because the time was 1 second. So for this case, na kama time haingekuwa 1 second, kama time ingekuwa tofauti. So we use the two formulas. We have the formula of flow rate. You can write somewhere flow rate is equals to volume over time is equal to AV. We use all the formulas here. Albert?
Yeah, hapo juu. Hapa.
So we use the two formulas of flow rate. Flow rate can be volume. Kumbuka volume over time ndio ilikuwa inatusaidia kuderive, ndio tukapata the other formula of flow rate to be cross-sectional area multiplied by what? Multiplied by velocity. So for volume over time, we already have the volume in 1. Na unajua flow rate lazima the SI unit ikue per units time per second. Where do we get this per second? So we have the volume to be 8 multiplied by 10 raised to power negative 6 as the volume in the numerator over the time given in the question. We were given that from the question, the pistons move from A to B in 1 second. Umeona sasa kama usipoweka over 1 second, 8 multiplied by 10 raised to negative 6 over 1, usipoweka over 1, you are likely to fail if the time haingekuwa 1 second. Kama time ingekuwa for example 3 seconds na umesahau hiyo 1 second hiyo. So over 1 is equivalent to, we have the cross-sectional area 1 centimeter square, which we can change 1 multiplied by 10 raised to power negative 4 becomes meters square multiplied by v, which is the velocity. Then you make v the subject of the formula. What is the answer? The answer is 0.08 meters per second. 0.08 meters per second. I want us to change the equation na tuweke ikuwe ilikuwa ni 3 seconds. Let us change the equation such that the equation now reads, the piston moves from A to B in 3 seconds. Then give me then we answer the question, what is the velocity of the liquid between A and B? Can we replace 1 second with the 3 seconds? Then we see. Give me the answer. The piston moves from A to B in 3 seconds. What is the velocity of the liquid between AB? What is the velocity of the liquid between AB? What is the velocity of the liquid between AB? Terence Gitau?
0.0267 meters per second.
0.02667 meters per second. Can someone else confirm if Terence, if you are getting the same answer as Terence? This is 26,489. 26,489.
I've gotten the volume flux as 2.667 times 10 to the power of negative 6 meter cubed per second.
Raised to negative?
2.667 times 10 to the power of negative 6.
Of negative 6.
Yes.
Where is Terence? Terence, what is your unit? Your unit of the unit of the answer? What?
Meters per second. Meters per second.
When you convert your answer to in standard form, what do you get?
2.667 times 10 raised to the power negative 2 meters per second.
So we want to know where the difference of the powers is coming from. Before that, let us hear from Enos. No, we have Elma. We have Elma. Elma from, that is a former member from 2 Cambridge. Eh? Elma, can we hear from Elma before we conclude the answer? 432.
Excuse me, can I have a suggestion?
Yes.
Since the distance between A to B,
since the distance between A to B
is 8 centimeters, which is alternatively 0.08 meters.
Yeah, in meters, yes.
Yes, and velocity is equal to displacement over time. So could you say that that is just 0.08 divided by the 3 seconds?
Proceed.
which gives us the 0.0267.
0.0267, yes.
Yes, which is probably the velocity.
The velocity, thank you. We have someone else, 377. 377.
(2.667 times 10 to the power of -2 meters per second).
Now, someone who got power -6, are you in agreement with the, have you noticed where you might have went wrong or you need some clarification? 489.
I think I need some clarification.
Okay. Seth? Seth?
Sure.
Yes.
Yes. Can you explain the working for the question? I haven't understood well.
So from the first question.
No, the question that you are doing.
Okay. So the question is, what is the velocity of the liquid between A, B? For the first question, tulitumia tu 1 second venye iko. And the formula that is guiding us through this question is the formula of flow rate, which is also the same as volume flux, is volume over time. Na tumesema time inakuja kwa nini? Time inakuja kwa sababu ya flux. Sini kama tu volume flux. Before tuweke flux, the formula is volume is equals to cross-sectional area multiplied by the length. Na tulitumia the length to be D. Now, so the volume, the formula we are using here is flow rate is equals to volume flux. Flow rate is equals to volume over time is equals to, we have the formula cross-sectional area A multiplied by V. V for this case is what? The velocity. Then we already have the volume of the liquid in point AB. We have the volume in A, part A, which is 8 multiplied by 10 raised to -6 cubic meters over time. Ile ya kwanza ilikuwa time, the time was 1 second. So we can use, tulikuwa tumechange sasa hii ikwe 3. Hebu tuweke over 3 seconds is equal to cross-sectional area of AB is 1 centimeter squared. Can we change now 1 centimeter squared into meter squared? 1 centimeter na 1 centimeter squared is not the same. When we convert 1 centimeter itakuwa 0.01. When we convert 1 centimeter squared into meter squared, the relationship is 1 meter squared is equals to 10,000. Therefore, when we change this 1 centimeter cube, it will be 1 multiplied in standard form, 1 multiplied by 10 raised to power -10. The value now changes to meter squared multiplied by V. Now, you have the calculators. Tumetumia 3 instead of 1. Tumetumia 3 instead of 1. Now we have in the first part of it, we have 8 multiplied by 10 raised to power -6 over 3 is equivalent to The two formulas are the same, is equivalent to, because this first formula leads us to this other final formula, AV, which is equal to 1 multiplied by 10 raised to negative 4 multiplied by V. Can we now cross multiply and give the value of V? Or you can first find the first part here, volume over time, or to pay value, then you equate with the other part. Let me also press the calculator here. It will be 8 multiplied by 10 raised to power negative 6 divided by 3 mwenye alipata power negative 6, huyo mwenye alipata power negative 6 amefanya flow rate power raised 2.667 times 10 raised to power negative 6, that is flow rate. Lakini swali yenye tumeuliza ni what is the velocity of the liquid between A and B? So can you now equate V over T is equals to AV? So this other side tuko na 2.667 multiplied by 10 raised to negative 6 is equals to 1 multiplied by 10 raised to power negative 4 times V. We divide both sides by divided by 1 divided by 1 multiplied by 10 raised to negative 4. We get the answer 0.0267 in decimals meters per second. In standard form, the answer for velocity will be 2.667 multiplied by 10 raised to negative 2 meters per second. Now, can you make sure that you wrote the formula, the working, and answer with the correct units? Can you check your working? Can you check your working if you indicated all the requirements of a calculation question? I hope you followed and notice where we left you. Question C on the same question. Question C on the same question. What is the velocity of the liquid between BC? What is the velocity of the liquid between BC? What is the velocity of the liquid between BC? What is the velocity of the liquid between BC? What is the velocity of the liquid between BC? Remember AB tuko na cross-sectional area na tuko na V. In AB, we have the cross-sectional area. We can even write in AB, we have the cross-sectional A is equals to 1 multiplied by 10 raised to negative 4 meters squared. We also have V yenye tumepata sahi, which is we are using the original one from the question, ilikuwa 1. ilikuwa over 1. Hii tumeongeza swali lingine. The original question ilikuwa 1 second, meaning we are referring to v, which is 0.08 meters per second. So our v, which is velocity, is 0.08 meters per second. So this one can be A1 V1. Now, what is the velocity of the liquid BC? We use the equation of continuity. We have the values, cross-sectional area 1 multiplied by velocity 1, we equate to cross-sectional area 2 multiplied by velocity 2. We don't have velocity 2, but we have the cross-sectional area. We have the cross-sectional area of BC, which is 1 millimeter squared. So we change 1 millimeter squared into, we change the 1 millimeter squared into meter squared. You can decide to change slowly by changing 1 millimeter squared. You relate it with the centimeter squared. You know that 1 centimeter is equal to 10 millimeters. So meaning, kama ni squared, it will be 1 centimeter multiplied by 1 centimeter is equal to 10 millimeters multiplied by 10 millimeters. But the millimeters is smaller than centimeters, meaning we have a negative. When we write it in standard form, it will be 1 multiplied by 10 raised to power negative 2. Hiyo itakuwa centimeter squared. Centimeter squared, we change it to meter squared times 10 raised to power negative 4. Inakuwa meter squared. You can still convert in your own way from millimeter squared to meter squared. You can change directly from millimeter squared to meter squared. You have that formula of the we have the formula. Some of you told me that Kenya has dug many dams containing magic. You use the initials and you relate the relationship between millimeters and meters. Then you give me the formula. If you fail, you can, this is where you can write the formula and fail to get the answer because of poor organization and not converting the units to SI units. If you mix the values of centimeters, millimeters, and the meters in your working, you'll not get the correct answer. You'll not get the correct answer. Can we also try this? We have question number 5. We have 9 marks from question number 5 on the screen. We have 9 marks from question number 5 on the screen. A lawn sprinkler has 100 holes each of cross-sectional area 8 multiplied by 10 raised to power 2 negative 2 centimeters squared is connected to a hose pipe of cross-sectional area 10 centimeters squared. If the speed of water in the hose pipe is 50 meters per second, calculate the volume flux in the hose pipe. So in this topic, ukiulizwa any value, you must begin by writing the formula. Begin by writing the formula. Volume flux or the flow rate is equals to cross-sectional area multiplied by velocity.